Hey, Rick. Great.
Yeah.
Yeah, when I was thinking, you guys could quite easily do Scott's graph. It looks to me like it should be informational. Not but it's informational graph based on, here's what we did. Document our experiences in IETF on, and like Spencer said, you know, the fact that it doesn't have security in it.
Yeah. So
You know, the fact that it could give us, kill us. But then there's also some kind of
so everything is a bit managed. When I open an array, I say open the array for each element.
Well, as you pointed out, because it's a collect, say, hangout, as soon as you run a
I
net,
can stop the
you're not
process
going to be able to receive
this
because it is unidirectional.
So that is what I did not.
So if you're on your local net, it's fine. It's great.
I know. Don't look at your watch and then look at me.
Let's do back to back with DTN and work on two problems. First off, the break. So everyone we had on Google and calls that. Didn't you tell them to come back? Yes. But we've had that time. It was like 11:05 and people were still presenting. So I think that's going to work. Yes, the break can't exist. Yeah.
Well,
We share a slot.
We should have done joint sessions.
We should have done a joint session. I think we need to ask for one of the big fan sessions and say, we'll do a joint.
Well, I don't think that's really trying, right? Because like him and the Ponte meet in the same slot, but in the middle of the session, you change chairs and all that stuff. So it's like, you know, two separate meetings in the same room versus a joint one, right?
I mean, the irony was this DTN meeting was busy because we had some work and a bit of, oh God, we're going to fit this in. There's a discussion on that, but it could have been without that big PCL discussion, it would have been 45 minutes tops.
Yeah, I love to start at the room.
He stopped you.
I got an emergency WhatsApp.
You made it just in time. He was just about to mention how the presenter wasn't even here. Okay, well, we have 3 people. Right? One's a presenter. Yeah, they're staying. Okay, well, let's go.
All right, everybody.
Okay, we're gonna start.
Welcome to Manet. We're gonna start, even though there's not a lot of people.
We're gonna pass around one blue sheet.
We can do a circle of chairs. It's all very.
Or we can pass around like 7 blue sheets and they could all be signed. It doesn't matter.
There are chapels.
Okay, and the funny part about here is that the agenda's pretty full today. The administrative stuff, please speak into the mics. Please state your name before you speak. What is this? Please speak into the mics. How close do I have to get this thing? Is this better? Okay. We need a jabber scribe and some note takers. Any volunteers?
I'm not blocking the jabber.
Okay. We have a jabber scribe. We need a note taker or 2.
I believe it's up. Rick?
Someone remote can also scribe.
Oh, there's one.
I I guess that answered that question. Anybody on the remote want to scribe?
I'll take those worst notes.
It's okay.
It's okay.
We'll let you.
Rick, I'll share the job.
Here's a interesting slide. Read it at your leisure on intellectual property. As you all know, the IETF's gotten more and more concerned about intellectual property. And there's the nut well. So as Adrian Farrell used to say, note well, the note well. So we did the note takers, we've done the Jabber Scribe, we've got the blue sheets. Here's our agenda. Lou Berger's going to talk about some DLEP extensions. Then we've got a remote presentation on Meet Echo from Christos on multipath chameleon, which is some routing protocol work that's been done. Ed Borain's going to talk to us about asynchronous network management, specifically in VTNs. And then Rick's got a short presentation on some multicast related data items for DLEP. So let's look real quick at document status. Right now we've got 2 documents in publication requested, the LID extension and the multi-hop forwarding extension for DLEP. The LID extension's been in that requested status for almost 80 days. So we're trying to figure out what the logjam is there. It's been a while.
Rick Taylor, please, can you unjam LID? I have running code. I'm getting demands from industry for it. Please unjam. I'm looking at ADs, chairs. The more dots, the better. Can we unjam it, please?
Hi, Alur Ratana, routing AD. Yes, it's my queue. I'm the logjam. They're next on the list, all 3 of them.
Yeah, we understand you've got a life like the rest of us, but it has. I think when I looked the other day, it was like 78 days it's been in that status. And,
Yeah, it's called head of line blocking. So there's other drafts in front, and
Okay.
So yes, I'll get to that soon.
All right. There's also one doc in AD evaluation status, and that's the control plane pause, and it's been there for a while. I don't remember how long. And then 4 docs that are active. Oh, go ahead.
Same answer.
Okay. 4 docs that are active. They're either through last call or getting ready to go to last call, and Lou's going to talk about those in just a few seconds. And there they are. So that's all we've got from the chair slide set. So I would say, Lou, you're up.
So we have Jabber running here. So if we hear a ring and I stop and look down, it's not because I'm texting, it's because I'm looking at Jabber. Hi, I'm Lou Berger. I'm going to talk about DLEP extensions. This is work I've been working on with Dave Wiggins and Bonan Chang. Next. Oops, that's great. Thank you. Whatever you did was correct.
Right, yeah.
Oh, wait, no.
Oh, you have the clicker. Go
All right,
for it.
whoop. I got it.
All right. I'll leave it alone.
Thank you. The font did something a little funny here with rendering to PDF, but I think we can get the point. I think we just talked about the latency extensions, so I'm not sure how much more. No, I'm sorry, we didn't talk about latency. We talked about the other one. So this is a document that's post last call. the last call completed in February. We addressed the comments as best as we could, published an update, and we didn't get any complaints. So we think we're ready for pub request on this one.
I agree.
Awesome.
I looked at that, and it's a really simple document. I think everyone's had time to look at it. If you haven't, then well, there's always IETF last call, but it's really simple. I'll do the write-up on that and move it forward.
Thank you.
Unless there's an objection in the room or on list, I'll take it upon me to do that very soon.
And the lower ones were the ones I was referring to, that those were already discussed on the previous slides. Now I heard a ring. Do we have something?
No, I didn't see it.
Okay. So I'm going to talk now about the active working group documents, as well as one individual draft that we've talked about in previous meetings. It's all on the topic of credit-based flow control, and it's a set of extensions. We have, these documents have a bit of a history. It actually started with a document that Stan wrote, and that got modified. The concepts got modified a bit and ended up in something that was DLAP flow control. And along the way, there were some decisions to split the documents apart. That's why we have a 0-0 that we're noting that we think is ready for last call. The reason why we think it's ready for last call is we've taken the last action that was identified as being open on that 0-3 document. Actually, I guess we started with credit extension and broke it into these three. So I'm going to go through them a little bit more, but we think the first three are ready for last call. As part of this process, we identified that being able to do traffic classification based on Ethernet headers is a good thing as well. Sort of actually almost more aligned with DLEP than IP, but so it's funny it's coming last. But we have an individual document on that, and we think that that should be adopted by the working group. It'll be interesting to see how much work we want to do after we go to adoption. We may find we're going to go rapidly to last call right after adoption. That said, I think every author thinks that. So once it comes into the working group, we'll figure out what really needs to be done.
Rick Taylor, I fully support the adoption of the Ethernet TOS field credit extension. A bit like the traffic classification draft, it was part of the other document, which was pretty mature. The fact that it just got split out means we should be able to turn it around fast.
Thank you.
Actually, Rick, again, this actually raises a larger question. The reason we were splitting it out was to make sure that DLEP extensions existed in their own document, so that if you supported extension blah, there was a document called blah. So the reason why the Ethernet and the DSCP extensions were split out into separate documents, despite the fact they are almost a cut and paste with a replace for the word Ethernet and DSCP.
Yeah, in fact, I missed one of those when I first
read
published
it, and it's just
the
like, oh, that's the wrong word. Does it make sense actually to say, well, why can't we just put two extensions in one draft to save on this?
So I think you're actually presenting my slides for me, which I'm not at all opposed to. But you really are saying the same things that I have here, and that's actually great, because what it shows is that I'm in sync with the working group, which is really what at least with Rick. As Rick was talking about, we had in the working group in previous sessions talked about that it would be worthwhile to split the functions that are being defined within the document so that they can be recomposed in different ways. And that, yes, credit control is an important thing on its own, but so is traffic classification. And that in the future, we might want to do traffic classification without credit control, and we should be able to specify that, that we can reference the RFC that brings in just traffic classification and doesn't bring in credit window control. And that was the reason for the split. I'll say that this was asked of the authors, and we did that. If the working group preferred to publish it together and we could get through the process faster, we'd be cool with that, but we also buy into the rationale and the discussion.
Sorry, I'll keep it quick. Rick Taylor again. I was the guy who asked to split these simply because I want to do metrics per flow. Hence, I wanted to refer to a document about flows without bringing in credit windowing. My previous question was whether just because it's a new extension, do I need a new document?
All right, so that I think you're now getting to the bottom part of the slide. So the other thing that we did is we do have a split of the DiffServ aware credit window extension, and here we're now talking about extensions, not data items, and the 802.q or Ethernet credit window extension. And the reason those are two separate documents is that so you can specify that you want to do Ethernet credit windowing or IP credit windowing and be clear what you're specifying. So that's both from a vendor standpoint as well as from a provider or user standpoint. You want to know what you have, because if you don't split them, we can have a router that says we're conformant with the extension and a radio modem that says it's conformant, but one does Ethernet and one does IP, and guess what? They don't work together. So that's the reason for that split. And that's reflected in the working group document, which is the DiffServ aware one, and the individual document. As Rick said, these are basically identical documents, but define a new extension value for each of those operations. And just as a reminder, excuse me, as a reminder, we have Ethernet traffic classification defined in our base traffic classification document. Why is it okay to have Ethernet and IP together in that document? Is because that document just defines data items. It doesn't define the use of the data items. The use of the data items happens in the extension documents. Those should be separate. And that's why and you'll see that reflected on the bottom. The big thing in the extension documents is they do this. For those who are remote, I pointed to that they ask IANA for an extension type, which is the key identifier to say what function we're performing. So what's next? We think the top three are ready for last call. We think the bottom one is very simple. As Rick said, it's basically the same document as the DiffServ aware credit extension, but we've done a SED, and replaced DiffServ aware with Ethernet or IEEE 802.1 headers. Now, on that last document, we think we'd like to adopt that one. Now, if the chairs said, well, we'll adopt it last call all four, that actually would be our preferred outcome. We thought it was a bit outrageous to put that on the slide. But really, hey, I'm an author, I want to get my document done. But if we're not going to do that, this is the next best thing, is we'd like to see the last call, the existing working group documents that we've gone over and have been stable basically for I think 2 or 3 IETFs now. They've been technically stable. It's just the editorial stuff we've been getting right. And I do think those were good changes. It's not that it was unnecessary delay. We now have the documents in the right form.
This is Stan again. I agree with you. I think we ought to. I think we should put the 3 documents you have listed there into last call, and then also call for adoption on the mailing list.
Okay.
And because of that, I don't think we can bundle all 4 of them together because of the extra step. But
it's the working group chair's call, but I think that's completely reasonable. I thought it would be a bit outrageous for us to say, let's last call an individual document, although that has happened on a document I've authored in the past. But it's unusual.
Hi, Alvaro Rotana, Routing AD. I don't necessarily want to add more documents to my queue since I'm already late, as you pointed out in your first slide. But I just wanted to point out that according to one of the RFCs that I forget the name, the number of, that talks about the working group process, it is up to you as chairs to decide whether you need to working group last call or not. So in other words, if that Ethernet draft is, as you guys already talked about, is pretty much similar to the other ones, and there's no contention, you could adopt and request publication.
Okay, that point taken. I was just a little bit concerned about lumping too much together, because right now I figure it's the same chance as all of us being struck by lightning right now. Thank you. Didn't happen. But we could ask for working group adoptants of the Ethernet credit extension, and find somebody with some kind of odd, out of left field concern that none of us thought of. So I'm just trying to be inclusive and let the process work. So once we get it adopted, then sure, we can last call it pretty quick.
Rick Taylor, the pause between adoption and last call for this is possibly worthwhile in case of IPR declarations, because I know there are lots of people doing DLEP-ish things out there.
I know the authors have no IPR to disclose whatsoever.
Yeah, equally, I have no IPR to disclose either, but it just that a small lull just to let people catch up and possibly raise fingers is probably wise in this case.
I'm a firm believer of doing formal IPR polls also, as people know from other working groups. Out of curiosity, does anyone have any comments or objections on any of these documents? Okay. I do want to point out that my co-authors have some code published, open source, for DLEP. They have made an update. I meant to check before I came up here whether or not that got pushed. The hope was, before I stood up and talked, that update would be available on the repo. And that change was to put in sub-data items. And the putting in sub-data items turned out to be a little more complicated than I would hope for. And my perspective, this isn't the implementer's perspective, who's David, my perspective is it's because the implementation was done first without it in mind. So some of it had to be refactored. We did actually talk about a simplification that would have made his code easier to implement, and agreed that it would not be the right format for the standard. Is that it actually was an unnecessary restriction that would hinder how we did sub-data items in the future. And what we had in the document was better, even though it made his implementation work a little bit harder. But it wasn't a big deal. I mean, in the end, he's done it. It's available. It's tested.
I'm sorry, I'm going to have to close the mic for time.
Okay.
Well, in that note, I'll move off.
That's, I mean, you got a couple of minutes, but I'm worried about,
I do have one thing I would like to bring up regarding the multiple documents, kind of a direction toward Alvaro and maybe the group in general, is do we want to continue proceeding with having one extension per document, or is there a way that is specified that the IETF uses where you can specify multiple extensions so that it's RFC XXXX.2 or some subset of that extension.
This is Stan. There was an incredibly smart man who sat in an IETF with me. I think it was Prague, but I could be wrong. Who iterated or who explained the case of, if you're going to put multiple features into one document, then you let implementers then pick and choose which feature they want, but they can still claim compliance. And I believe he's the same really smart guy said it again right up here right now. So my vote would be no, for exactly the reason that Lou has commented on multiple occasions with me in the room. And that's that one-to-one. And that way, if you say, I support RFC, blah, 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 every piece of functionality that's in that document is in the code.
Yeah. I agree with that, but if there was a way that you say you support that RFC, you support everything in that RFC.
Right. I
Where
think
if there
that
was a way to-
options lead to interoperability issues.
I wouldn't
So
say-
I'm in as a sort of, from a philosophical standpoint, I want to eliminate or minimize options in a document.
And like I said, this is more of a question of how the IETF kind of wants to function with those drafts. Is it a problem having, 100 DLEP drafts, extensions as RFCs?
Hi, Alberto Rotano, Routing ED. It is up to the working group what you want to do. Personally, just because they're going to come into my queue, I'd rather have less documents to read. But this is not the only working group that at this point has been made about compliance and RFPs and things like that. Sure, you could ask in the RFP, do you support RFC 5, Section 2, but that gets really complicated and really not nice.
Okay.
So if the working group wants to publish whatever number of extensions in different RFCs, that's fine with me, and that's fine with the AAG in general.
Alvaro, quick question. Is it better for you to get the documents as a set or spaced out over time?
It depends. The only thing that's probably interesting to me is whether you want them published as a set or not.
You'll end up with the ones that have dash extension being in ref weight on the other two. The other two can be published independently, but the second two depend on those first two.
Again, either way, to me, what's important is whether you rather have them published together or
I
around
think
the same
publishing them
time.
as a set makes a lot of sense, but is it required? Absolutely not.
No, and the other thing about that is that you may want for them to be processed together, around the same time. Another one is, do you really want them to be published together? Meaning,
I think it'll make the
consecutive RFC
reviewers
number or
life.
something.
I think it'll make the directorate reviews easier to manage them as a set.
Yeah, I've done with other working groups. We've done that before, where we have the multiple depending documents together, and not just for the directorates, but for the AAG and everyone else. And usually, what I end up doing is sort of providing a little roadmap and saying, this draft is the first one you should read, and then read this other one because there's a dependency or whatever.
Yeah, exactly.
And then it's easier for everyone to understand. I agree about that. Yes. So if you do that, let me know what you want, and so that I don't have to necessarily guess what all the dependencies are. That way I know the best thing to do. Yes, thanks.
Rick Taylor again, very quickly, talking about RFPs, the incoming RFPs I've seen about DLEP have actually specified extensions, not numbers, mostly because most of them are in drafts. But people seem to be talking about, I need this extension, I need that extension.
So that argues for collapsing them. Or I should say it argues against separating them.
Okay.
All right, thank you.
Let's take it to the list. For the next presentation, I'm hoping Christos is online, and we need you to enter the queue from Meet Joe or Meet Echo, so that we can.
Should try to talk. We're trying to. Is he trying to talk, Lou? Yes. Yes, I've started to write notes on separate.
Hi, guys.
We can hear you.
Okay. Do you have my slides actually, or shall I project them from here?
We do. We have the slides up.
Excellent.
Not only do we see you, we wish we were there with you.
It's very hot. It's very hot. Well, I don't have a good internet on the room actually, so I decided to come down by the pool actually, so make a good a good scene for you. Let me. If I actually, shall I start with the presentation then?
Yes. Yes. Go ahead.
All right, guys. So essentially, maybe you remember us. We submitted a couple of years ago. It was Arvin Ramureka, one of my actually submitted a draft. It was called Chameleon back then. It was submitted, I believe, in 2014 in IETF. I think he went to your meeting in Amsterdam, presented it there, I think, and then I think he was in the States at some point, present there as well. Since then, we tried to commercialize it. We haven't been very successful, to be honest with you. I'll be honest. And thus we are continuing on the research path. So I'm down here. Actually, I'm in Malaysia at the moment, and in Thailand earlier this week, actually, because we have a very big project funded by the UK government. It funds 3 UK universities, Kingston, Surrey, and Glasgow in Scotland, to work with Malaysia, a few universities in Malaysia, to set up, let's say, a network, an emergency network, actually, to support these communities when there is any catastrophic events, like the tsunami a few years ago. So that's the reason I'm down here, actually, in Malaysia, actually working with these guys to set up a prototype. We are actually 1 year and a bit on the project. And as I said, actually, Sara is part of the team. Can you hear me? Yeah, I'm okay.
Yep. Yeah, you're fine.
Okay, great. And Sari actually provide the 5G infrastructure, so essentially you have a 5G extension to that. Kingston, since it's, as I said, actually long time ago, we work on Manets, so we continue down that path on the research side of things. So we do a bit of commercial activity on Manets, but I'm not going to talk about this here. So essentially, as I said before, my ex-PhD students, Arvin Ramerka and Grant Miller, actually created designed the protocol which was called Chameleon. Chameleon was a kind of a hybrid protocol between proactive and reactive routing protocols, very well defined by the IETF. So I'm not going to spend time, obviously, talking to you about these protocols. So essentially, we thought to continue down, further designing and updating the protocol. So what we have done, we have created a second version, if you like, of this Chameleon protocol, which is called Multipath Chameleon. We are currently working on this on a prototype level as well. As I said, actually, I'm here in Malaysia with the guys to set it up on the campus, one of the campus in the capital. Malaya University is the partner here, local partner. So essentially, the plan here is actually to create a kind of a new protocol, still based on Chameleon, with 4 phases of operation. It has still a proactive and a reactive phase. Still has this oscillation phase. I know actually long time ago when we presented in IETF, we got a lot of comments and a lot of ideas for improving the protocol, especially the oscillation phase. So what we've done actually in order to improve it, and we got a lot of comments on board, is actually to create this monitoring phase. So we have added actually a new phase, if you like, which is called monitoring phase. And we have created a further 2 Chameleon messages. One is called the hop count request and hop count reply. So the overview.
Which slide? Because I'm trying to present your slides. Which slide are you?
Slide 4 now. Slide 4. Yeah, sorry about that. Slide 4.
4.
Okay, just let me know when you want me to change the slide from.
Yeah. Fine. I cannot actually. The problem is I cannot see anything on my screen. I don't know why. Maybe I don't do something correct. Yeah. Anyway, getting back. So on slide 4. Yeah. So essentially, a quick overview of the protocol. So as I said before, it has 4 phases. One more phase from the initial design of the protocol. We are working actually the multipath extension of OLSR version 2. and the reactive side is actually on AODV version 2. So during the monitoring phase, which is the new phase we have designed, this phase actually is triggered by this hop count request when are received actually by the node, and then this monitoring phase is actually run within the proactive phase. Now, the reactive phase is triggered when the network, depending on the current scenario that is being kind of run on our algorithm, favors reactive, let's say, parameters, reactive statistics. So in that case, actually, we're using the monitoring phase to trigger, if you like, the reactive phase. Now, at that point, at that specific point, the transition between proactive and reactive is actually dealt with by the oscillation phase, which is the same with the prior, if you like, protocol, called the Chameleon protocol that was submitted to IETF a few years ago. So now I'm slide 5. So the prerequisite here is to create a set of network scenarios. This is different from the previous protocol, which is particular specific to the individual routing protocols, either reactive or proactive. So for this, if you like, specific submission, we have created 4 scenarios by changing the node density, the node mobility, energy consumption, and the quality of service requirements, mainly the delay constraint. What we have done, I've actually investigated and selected the scenario by running NS3 simulation. So we use the NS3 simulations actually to identify the best suited scenarios for our case. Our case, one more time, I say, is based on emergency, on an emergency situation, or an emergency case. So the adaptive mode module inside the node analyzes the network scenarios and then triggers the appropriate phase. So this is, as I said, is new from the previous Chameleon protocol, this monitoring phase. If I go to slide 6 now, where essentially you have a visual representation of what I presented. So essentially, this shows you the how the algorithm works. So you have a Manet deployment. Again, I stress that this is an emergency deployment. And we enter the P phase of the protocol. Then, depending on the hop count request, we are actually running the M phase within the P phase. Then, depending on the network scenarios that we have selected, in that specific case, we have actually 4 scenarios. We are actually monitoring the situation, and then depending on the obviously how dynamic the network is, adaptively we are actually switching using the oscillation phase from P phase to R phase. So essentially, if I want to kind of summarize it, we operate mainly on P phase. So P phase is, if you like, the default phase. Then, depending on hop count request and the monitoring phase, we switch, if needed, using the oscillation phase to R phase, to the reactive phase. Quickly on slide 7, which is the actual algorithm that we have implemented on NS3. Again, as I told you earlier on, we have 5 phases. So the default phase, which is the P phase, operating on multipath OLSR version 2. We have the reactive phase, which is on OLDV version 2. Again, a mental note here, that we don't use at this specific point the multipath AODV version 2. We use actually the clean AODV version 2. So this is, if you like, a kind of efficiency of the current design. But our next, if you like, release hopefully will be able to accommodate the multipath extension of ODV version 2. Then we have the M phase, the monitoring phase, which essentially monitors the hop count requests. So depending on the hop count requests and using the adaptive module, depending on the network size threshold, which again depends on the certain characteristics, as I told you earlier, the mobility, the quality of service, then the dynamicity of the network, and so on. It switches, if it needs to be so, to using the oscillator phase to a reactive protocol. In our case, actually, ODV version 2. If I go to slide 8, please. So balance balance point between P phase and R phase, so proactive phase and reactive phase. This depends on the network size threshold. Again, this is to stress here that this hasn't changed from the previous design of our Chameleon protocol, which essentially, again, it still used the network size in order to decide if it moves from proactive phase to reactive phase and back. Oscillation phase avoids group and periodic oscillations. So essentially, what a comment we got back when it was presented in 2014, 13-14, was that what happens if the network stays for a long time in oscillation phase. So essentially, the network starts oscillating. I know this is a problem, a deficiency of this current design. We try to, so if you like, sorting this out, to have put the maximum hop count action, which is essentially depends on the number of hops, and usually we take the 2 hops scenario before we actually switch to oscillation phase and then eventually to R phase. You know, and especially this is something which is ongoing. It is a known problem for us, and this is something we're going to continue working on. And finally, is the last slide. Slide 9. So future directions, what we plan to do next. Of course, very important for us, and I'll start from the end, is still to continue our work with you guys and the Manet working group. As I said, we are all the friends of yours. We were away for a few years, but hopefully we'll get back on with this new design. The next, in terms of technical characteristics, the next step is actually to add multiple version of the reactive phase, or AOMDV, and implement that fully on NS3. Also, the other thing we need to actually select further scenarios. At the moment, we have 4 scenarios. We want to work on a bigger number of scenarios. So essentially, the pool of network scenarios are actually increased, and thus you have actually better, if you like, statistical, if you like, pool to select from and make your system a little bit more intelligent, more adaptive the routing scenario. So this is the second thing we want to do, and obviously we want to continue working on the simulation side of things, on the empirical side of things, by creating this a new protocol actually on NS3, hopefully making it available on there for the global community to work on Manet. And
Okay, Christos, I hate to interrupt, but we are really time constrained, and I know there's a question, so we need
no
to make it
problem.
brief.
No problem. That's fine.
From the chair's perspective, my only question to you would be, you've listed out some future directions. Do you also envision as one of your future directions that you would be asking the working group to accept this document and move it through the working group, or is this more of an informational type thing?
We would like to that actually, move it through your working group. I know it takes time and it takes effort, but obviously, if you get good advice from yourselves, guys, hopefully we'll make this a working document. Yes.
Okay, Charlie?
Okay, my name's Charlie Perkins, and I'll make it quick, but I just have a couple of questions. First of all, there's a monitoring phase. Where's the monitoring occurring? I mean, is there part or a distinguished device in the network that's doing the monitoring, or is it some sort of distributed monitoring, or how is that?
Yeah. Hi, Charles. I think we worked in the past together. Maybe we worked together with my student Arvin. Maybe you remember him. Actually, he came with you to in I think it was in Amsterdam when he presented the initial chameleon protocol. Good to see you. Good to see you. So essentially, yes, the monitoring phase. Let me get this is slide number 7. So the monitoring phase actually is part of the adaptive module that was in the previous design. The only difference here is actually that, as I said before, is we monitor the hop count requests. This is definitely, the plan here is definitely to be distributed. And first thing, and the second thing is actually we want to use some type of artificial, if you like, intelligence to train the system. And for us, in order to train the system, what we need to do, we need to have more scenarios.
And does your
To be fair to the other presenters, I'm going to have to cut this off right now because of time. I mean, we're just
okay?
I
Well,
do think it's an interesting discussion.
Charles, I know you well actually, so we can get. I know you. Probably you remember us as well.
Let's go to the mailing list with this, and because this is good stuff, and I think we should keep talking, but we've only got an hour.
Yeah, I think we don't have time today, but we should take this to the list, and it's an interesting development in terms of future of Manet and possible work. I don't know that the specifics we can get into on the list about how a new dynamic using AODV v2 and OLSR v2 protocol could work, and if that's something the working group wants to work on. That seems like the logical next step, but again, we should take that to the list and have details worked out on the list and in the future.
So if I may say one last thing, guys, before I go, it is very big. As you know, there's a lot of big discussion at the moment, both on the 5G world, IoT world, or whatever, on working on the periphery of the network. So I think Manet probably starts becoming, if you like, a hot topic again. So let's see.
Thank you.
Thank you very much.
Thank you.
Ed Brain. And also, Ed, I know we had talked about the length of your presentation. It would really help me if you could go at about 10 minutes instead of 15. Okay. There's a clicker here if you'd like.
Thank you. Hi, my name is Ed Brain. I'm from the Johns Hopkins University Applied Physics Lab. I'm a member of the DTN working group. One of the things that we have been working on in DTN is what does network management look like in a DTN? And looks a little bit like this. So, can you adjust? I'm on an unaligned boundary. So one of the things that we had started looking at in DTN was how do we manage a delay tolerant network, and how do we manage a case where we have constant disruptions, we cannot assume sessions, and in particular, we cannot assume a pull model of information. And we looked at that from a couple of different perspectives. We looked at it from the challenges that New Space is looking at from certain sensor networks, vehicle networks, other resource constrained networks. And the way we distilled the problem was to say that if you look at some of the most constrained use cases we have, which are spacecraft fault management systems. So I did flight software for New Horizons, which was out past Pluto. We really didn't have a concept of a timely round-trip data exchange. And we wound up having, there are interesting stories about that after the working group, but we wound up coming back and saying autonomy models for fault management are necessary. We do not need sessions associated with that, and we know how to do it, and pretty much all spacecraft do it in about the same way. There are proprietary differences, but from a logical decomposition, they do it about the same way. And it is not the way that we manage networks in data centers today, because we have high availability links, we have standards and open source tools, and very large investments. The question that we're trying to answer in DTN is there a motivating overlap between these highly autonomous but very customized management systems and the more commoditized high-rate pull session systems? And we came back and said, we think that there is a use and a utility for creating something that lives in that overlap, and that is what we are starting to put forward in DTN for network management. Next slide. So we coined the term asynchronous management. And it is the idea that we are looking at open loop control over a network where the devices have high disruptions and high delays, either as a matter of physics and signal propagation delay, or simply as a matter of priority or the cost associated with maintaining those connections. And in that, we had decomposed the work into 3 layers. The first is something called the asynchronous management architecture, which laid out sort of the logical decomposition of how you would do this and what logical data models, roles and responsibilities and system properties would be there. For all intents and purposes, it is like a requirements document for how one would do asynchronous management. Second from that, we created a physical data model. We called it an application data model, and it is primitives associated with that model and how you would communicate them. And examples are shown here in terms of externally defined data, literals, operators, time and state-based rules and reports, and strongly typed variables. And these should not be particularly new for anyone that is looking at doing different kinds of management. The important part of this is that the definition of management in this case is not simply performance monitoring of reports coming back. It is open loop control saying, I need to configure the device so that when I cannot communicate with you, these are the responses I need you to take. This is the data you need to know when to report and when not to report. And that requires more than just a table and report semantics. And then the last is something called the AMP, the Asynchronous Management Protocol, which is one of potentially many encodings of that data model, in this case using CBOR. And my last slide, if we go to it, is we are starting to standardize this. Well, we have many drafts that are coming forward in the context of the DTN working group. The first, the AMA, is out there. It is a personal draft, but it is being put in as a DTN working group draft, AMA 07. And if you are interested in this, that is the place to start looking in terms of overall what we're trying to accomplish. In terms of the data model template and the JSON encoding of that template, what we have done is taken several applications and protocols associated with DTN, a generic bundle protocol data model, a bundle protocol security model, and so on, and captured what it would be like to manage those protocol agents. And then we've taken some open source implementations for things called ION, which is NASA JPL's implementation of DTN, and created some data models associated with how to manage those specific applications and not the generic protocols. And we've put that together and released it and are continuing to maintain that reference implementation open source using the AMP protocol, which will be the CBOR encoding of both the encoding of the objects between agents and managers in the system, but also it implements the full set of autonomy specifications that you need to do the kind of things you want to do end to end. So the reason that we're hoping to bring this up to this working group is to come back and say part of our motivation was new space, part of our motivation were sensor networks, and part of our motivation were mobile networks. And a question out to the group, one is if people are interested in this, to please go look at some of the specs and provide comments. and also to try and help us understand what the kind of network management challenges you will face when you're trying to manage these highly mobile networks. Okay. So otherwise, thank you very much.
Thank you.
Very quick comment. Rick Taylor, as working group chair of DTN, we are kind of taking this around outside of DTN because we understand that we can't just come up with entirely our own way of network modeling, network management. So we've been going to NMRG, NetConf, NetMod. Well, actually, we kind of went to NetConf and they said go away, so we took it to NetMod. But we went to the wrong place. But we're going around the working group, so this we think has relevance elsewhere. All expertise, as Ed said, all comment, please.
All right, next speaker, Rick Taylor.
Yeah, okay.
And we've left you with 5 minutes.
Okay, I'll be quick. So this is a pre-draft concept that's the joy of the IETF meetings as you speak to smart people and ideas sort of start to consolidate. So just as a quick recap, there are two reasons for DLEP. One is based on the premise that the radio system knows more about what is happening on the local link than the router does. So it's a better idea for the router to go down to the radio system and say, what is going on? The second point is that if you can bootstrap a lot of your hello protocols, you can pre-fill your ARP caches, you can send around some initial data. In Manet networks where you have very short contact times, the more you can get chucked across the control plane of the radio, the better. It means your adjacencies, very short-lived adjacencies, are still usable. So I'm not going to read the slides, but fundamentally, multicast protocols and some other useful protocols rely on rendezvous points. There is something is elected in your 2-hop neighborhood or whatever that is used as a forwarding point for distributing. Now, a lot of the algorithms that decide how to elect a rendezvous point, they're either statically configured or they use a 2-hop neighborhood or whatever. The radio system underneath has its own topology built on its own physics and its own way of working. SATCOM, hub and spoke. You want to elect the hub to be the relay point. It seems a really sensible thing to say, but your routing algorithm may just go, hey, I've got 7 pairs. Which one should I choose? The one with the lowest ID, which happens to be a spoke. So there's some very quick examples there. So the proposal, next slide, please, is to allow a modem to inform a router that it is a good candidate as a relay. So the modem can say, hey, I'm in a good spot. I've got good coverage to all my peers. I seem to be in the middle of the cloud of local nodes. And the other part is to a router to say, hey, when you see a new, dear modem, when a new destination comes up, please tell him that I have been elected as the relay, because it saves you bootstrapping and it saves kicking off a new leader election or whatever. Okay, so although this is really useful for multicast, specifically PIN and that kind of stuff, this is orthogonal to the multicast components that are in DLEP already. So it's not talking about multicast metrics, multicast destinations, it's unrelated. Next slide, please. So how do we do this? A DLEP extension, of course. So we're proposing a new extension, and there's a question about this later on, which would introduce 2 new data items, which would be per destination data items. So one saying router relay point. Hey, I'm a router. And whether a router willingness to be a relay or whether it has been elected to be a relay. The election is out of band or over whatever algorithm is running. And the other data item would be the modem relay point, so that the radio system could inform the router to say, hey, I don't know how you're sorting out your relays, but you would be a really good candidate. Or the counter example is, actually, you'd be a really bad candidate. You're currently in a tunnel. You can only see one other peer. For God's sake, don't elect yourself don't announce that you're a good relay point, because you're not. Next slide. Yeah. So this is the proposed set of drafts. I've started putting some text together for a relay point extension draft. it's the standard boilerplate of IANA registration for extension point IDs, layouts of the data items, blah, 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 blah. I think there could be a second draft to say, given this extension, this is how you make it work with PIM. So how do I use this in order to become a rendezvous point for multicast? OLSRv2 uses two-hop neighbor discovery in order to elect a designated router. I'm trying to remember my OLSR2. We need some advice from that community. And you could use the DLEP extension to influence your leader election, possibly OSPF MDR. I know it was only experimental. I'm not sure how far through it got through, but it used the same principle of, well, let's form a little cluster and elect a leader. Questions?
Alberto Tana, Huawei. Just real quick, PIM and MOD are in the process of deprecating ASM, which means that you don't need relays anymore, right? Because most of the multicast that we see is single source multicast.
Yeah.
I don't know in the types of networks that we work here if there is a lot of any source multicast, and then you need the relays and all that stuff. I'm just saying this because if what you see is single source, then don't work on the PIM thing, right? There's no point in necessarily doing that.
But, and I'm not a PIM expert, there is still tree building, and for intermediate nodes within your tree, for branch nodes in your tree, they're effectively relaying if they're running off NBMA links.
Yes, it's not a rendezvous point. It's a relay in the other sense, right?
Yeah, hence
that is maybe the best path to the source.
Yeah, so I am a good relay data item, not I am the rendezvous point for your source.
So it may be more in the sense of everything else, which is I'm a better candidate to be a designated forwarder, for example.
Yeah.
Or a lot of those things.
Yeah. But good point about rendezvous points sort of disappearing.
Small question. How does this approach solve the problem of having the layer 2 its own topology, right? So
that's exactly what it's designed for.
No, because so when a node says it monitors its layer 2, it knows that it's very good in average, and then it sends a request to be part of the candidate relay set. At the end, you mentioned you have to be elected, meaning the decision to take him as the next hop is taken before the transmission and not after. So he tells me that he has a very good layer 2, so I say, all right, I'm using you, send it, and then like 1 millisecond after another, the condition changed because that's what wireless is about, and then it might not be that good actually.
Yeah.
Right.
Okay, so I've gone very quickly because we're short of time, so I've made a lot of assumptions about prior knowledge. The signals that are coming through are not sets, they are not demands, they're purely informational. So the radio can say, you would be a good relay. The router can completely ignore that. It may say, hey, I'm running on 2 AA batteries, I'm not going to be a relay. So it's purely informational transfer, and it can change over time. The DLEP destination update, you could say, hey, you're a good relay point, and then a minute or two later, it can say, you're not anymore. You're in a moving vehicle. You've disappeared. Don't be a relay anymore. What the other layer does is entirely up to the other layer. It's just providing more information. And following from that point, is this actually 2 extensions? Is one, so the router can say, hey, I've been elected a relay point. Perhaps link layer, you might be able to do something, and please pass this on to other people so we can do fast bootstrapping of who's the relay. And is the other extension the modem able to signal to the router up to layer 3 to say, you would be a good candidate or you would not be a good candidate? The question is this, and this goes back to the 1 document, 2 extensions, 1 extension that covers quite a few things, so 2 different applicabilities, use cases. I'm looking at the chairs, and this is probably a take to the list.
It's going to be taken to the list because we're already officially over time.
I'm happy to keep answering questions then.
So Justin Dean, just wanted to mention on OLSRv2, there's a willingness value.
Exactly. Yeah.
And I believe that's bits 0 through 8,
and
or 8 bits, and then on SMF, there's a router priority number that is a 1 byte field.
And that could be a classic thing where you could,
just feed right into
yeah,
that.
just drop straight in. I mean, and all those sort of relay protocols have a willingness and enable flag kicking around in some way.
Luberger, in the interest of limiting scope of information and improving layering, you might consider, instead of making the decision for the router, because that's what you're doing, is you're making a router decision, provide the information that is useful to the router to make that decision. So if what's really going on is you're identifying who's richly connected, have an extension that says connectedness. And then have a document that says, if you're running PIM, use the one who has the highest connectedness. And maybe I'll use that connectiveness, one day I'll learn to speak, connectiveness, for something else in the future.
This is Stan Ratliff. You have accurately explained the intent of what we're talking about here. The idea was not to do the decision for the router. The idea was for the modem to have a vector by which it could tell the router, by the way, I'm a good candidate. Now,
but that assumes the router, that assumes that you have to give the modem knowledge of the selection algorithms of what makes a good RP, basically. Rather than do that, just provide some additional parameters up from the modem to the router, and it can use it any way it wants. And today we're using it for multicast selection. Tomorrow we might use it for something else.
Yeah. Can I paraphrase? I think you're saying, my proposal, or our proposal is Boolean flag, good, bad. Your proposal is make it an integer called connectiveness. You know, you can see I am connected directly to 18 rather than 4, and you could use that as a...
Yeah, and maybe you have sub-David items that says I'm connected with them at this type of bandwidth.
Okay, that's
a link metric.
What's that?
It's a good point.
Let's take this to the list and we're done, guys.
Yeah, this was a proposal document. Comments, please.
By the way, I think it's great stuff and would like to see it.
So would I.
So it's not that I'm
I think
I'm
we got
speaking
something.
out against it.
I think we got something here. So
All right, thanks everybody.
Thank you. Did everyone sign the blue sheets? If you haven't, they're up here.
In our case, it's the blue sheet.
Yes. I'm going to sign this one over here.